Improper bonding is a possible cause, so ensure that the spa, pool, and surrounding equipment are properly bonded to the grounding system. Electrical leakage is another possible cause. Inspect the light fixtures, pump, heater, and other electrical components for any leaks. Corroded bonding wires can also cause issues, so check the continuity of the bonding wires and inspect them for corrosion. Improper grounding of the heat pump is yet another possible cause. Therefore, verify that the heat pump is properly grounded according to manufacturer's instructions. Loose connections can also cause this, so examine all electrical connections for tightness. The National Electrical Code, or NEC, requires a continuous bonding connection between all metal parts of the pool, spa, and associated equipment. Ground fault circuit interrupter, or GFCI, protection is required for all spas and fountains. To troubleshoot, firstly, measure the resistance between the spa water and the pool water. A reading of 5 ohms or less is acceptable. Secondly, check the bonding wires. Trace the bonding wires from the spa to the pool equipment and ensure they are continuous and properly connected. Thirdly, isolate the problem. Turn off the heat pump and other electrical components one at a time to determine if the voltage disappears. If the issue cannot be resolved, it is advisable to contact a qualified electrician for further investigation and repairs. If there is a tingling feeling, exit the water immediately. Do not use the spa or pool until the issue is resolved. Keep all electrical equipment away from the water. Regularly inspect and maintain all electrical components to prevent future issues. Ensure that the bonding is done with a solid 8 AWG copper conductor. This conductor should connect to all metal parts within 5 feet of the inside edge of the pool, spa, or fountain. This includes metal parts of electrical equipment, pump housings, metal conduit, and metal fences. The bonding grid should be connected to the pool reinforcing steel, if any. All metal parts must be bonded to create an equipotential plane, which minimizes voltage gradients in the pool area. The 8 AWG bonding conductor should be continuous, unspliced, and run back to the equipment grounding conductor of the pool pump or the panel board. Splices in the bonding conductor can create high resistance connections, which compromise the effectiveness of the bonding system. Mechanical connectors used for bonding must be listed for direct burial. Check the grounding electrode conductor size, which connects the grounding system to the earth. The grounding electrode conductor must be sized according to the service entrance conductor size per NEC table 250.66. The grounding electrode system typically consists of a ground rod, ground ring, or connection to the metal water pipe. The ground rod must be at least 8 feet long and driven into the earth. The ground ring must be at least 30 feet long and buried at least 2.5 feet deep. The metal water pipe must have a supplemental electrode, such as a ground rod or ground ring. Verify GFCI protection. All electrical circuits supplying power to the pool and spa equipment must be GFCI protected. This includes the pool pump, heater, lights, and any other electrical devices. GFCI breakers trip when they detect a ground fault, which helps to prevent electrical shock. Test the GFCI breakers regularly to ensure they are functioning properly. Use a GFCI tester to verify that the breakers trip within the required time frame. Inspect the pool and spa lights. Ensure that the pool and spa lights are listed for underwater use. The lights must be installed in accordance with the manufacturer's instructions. The lights must be properly bonded to the pool bonding grid. Check the light niches for water leaks, which can create a shock hazard. The pool and spa light should be powered by a low voltage transformer. The transformer reduces the voltage to a safe level, typically 12 volts. Verify the water chemistry. Imbalanced water chemistry can corrode metal parts, which can create a shock hazard. Maintain the proper pH, alkalinity, and calcium hardness levels in the pool and spa water. Test the water regularly and adjust the chemicals as needed. Do not allow the water to become too acidic or too alkaline. Ensure that the pump and filter are properly maintained. Pump and filter must be properly grounded. Clean the filter regularly to prevent it from becoming clogged. Inspect the pump and filter for leaks. Check the pump impeller for damage. Do not operate the pump if it is making unusual noises. Verify the heater is functioning properly. The heater must be properly grounded. Inspect the heater for leaks. Check the heater elements for damage. Do not operate the heater if it is making unusual noises. Ensure that the heater is properly sized for the pool or spa. Check the electrical panel. The electrical panel must be properly grounded. Inspect the panel for loose connections. Check the breakers for proper sizing. The breakers must be sized according to the opacity of the circuits they protect. Ensure that the panel is properly labeled. Do not allow water to enter the electrical panel. Inspect the wiring. The wiring must be properly sized for the circuits it serves. The wiring must be in good condition and free from damage. The wiring must be properly insulated. Do not allow the wiring to come into contact with water. Check the conduit. The conduit must be properly supported. The conduit must be in good condition and free from damage. The conduit must be properly sealed to prevent water from entering. Ensure that the conduit is made of a non-conductive material, such as PVC. Look for stray voltage sources. Stray voltage can come from various sources, such as faulty wiring, corroded connections, or damaged equipment. Use a multimeter to check for stray voltage in the pool and spa water. The voltage should be less than 0.5 volts. If there is stray voltage, try to identify the source and correct the problem. Turn off the power to the pool and spa equipment before working on any electrical components. Wear rubber gloves and safety glasses when working with electricity. Be careful not to touch any exposed wires. Contact a qualified electrician if you are not comfortable working with electricity. Grounding is an intentional connection from a circuit conductor, usually the neutral to earth. Grounding creates a low impedance path for fault current to flow back to the source, which causes the overcurrent device, such as the circuit breaker or fuse, to trip and to energize the circuit. Grounding also helps to stabilize the voltage to ground during normal operation. Bonding is the permanent joining of metallic parts to form an electrically conductive path that ensures electrical continuity and the capacity to conduct safely any fault current likely to be imposed. Bonding reduces the voltage difference between metallic objects, which helps to prevent electrical shock. The purpose of bonding and grounding is to provide a safe path for fault current to flow back to the source and to reduce the risk of electrical shock. Bonding and grounding are required by the National Electrical Code, NEC, to ensure the safety of electrical systems. Section 680 of the NEC covers the requirements for swimming pools, spas, and hot tubs. This section includes requirements for bonding, grounding, GFCI protection, and other safety measures. The NEC requires all metal parts within 5 feet of the inside edge of the pool to be bonded together. This includes metal parts of electrical equipment, pump housings, metal conduit, and metal fences. The bonding grid must be connected to the pool reinforcing steel, if any. The bonding conductor must be at least 8 AWG copper. The NEC requires all electrical circuits supplying power to the pool equipment to be GFCI protected. This includes the pool pump, heater, lights, and any other electrical devices. GFCI breakers trip when they detect a ground fault, which helps to prevent electrical shock. The NEC requires all pool and spa lights to be listed for underwater use. The lights must be installed in accordance with the manufacturer's instructions. The lights must be properly bonded to the pool bonding grid. The NEC requires the pool and spa lights to be powered by a low voltage transformer. The transformer reduces the voltage to a safe level, typically 12 volts. According to the National Electrical Code, specifically Article 680, several key requirements pertain to the bonding and grounding of pools and spas to ensure electrical safety. The NEC mandates an equipotential bonding grid for pools and spas. This grid consists of a network of conductive elements designed to minimize voltage gradients in and around the water, reducing the risk of electric shock. All metal parts within a specified proximity of the pool or spa must be bonded to this grid using a solid copper conductor of at least 8 AWG. This includes metal components of the pool structure, such as reinforcing steel, as well as metal appurtenances like ladders, handrails, and diving boards. Metal components of electrical equipment associated with the pool or spa, such as pump housings, filter housings, and heater enclosures, must also be bonded to the grid. This ensures that all metal parts are at the same electrical potential, minimizing the likelihood of a voltage difference that could cause a shock. The bonding connections must be mechanically strong and corrosion resistant, typically achieved through the use of listed bonding connectors suitable for direct burial. These connectors provide a reliable electrical connection that can withstand the harsh environment of a pool or spa area. The equipotential bonding grid must be connected to the electrical grounding system. This connection ensures that the bonding grid is at the same electrical potential as the earth, providing a low impedance path for fault current to flow back to the source in the event of an electrical fault. All electrical equipment associated with the pool or spa, including pumps, filters, heaters, and lighting fixtures, must be properly grounded. Grounding involves connecting the metal enclosures of electrical equipment to the electrical grounding system, providing a path for fault current to flow back to the source. This helps to trap over current protective devices, such as circuit breakers, in the event of a ground fault, de-energizing the equipment and preventing electric shock. All electrical circuits supplying power to pool and spa equipment must be protected by ground fault circuit interrupters, or GFCIs. GFCIs are designed to detect even small amounts of leakage current to ground and quickly interrupt the circuit, preventing electric shock. GFCIs are typically required for outlets within a specified distance of the pool or spa, as well as for circuits supplying underwater lighting. Underwater lighting fixtures must be specifically listed for use in pools and spas and must be installed in accordance with the manufacturer's instructions. These fixtures typically operate at low voltage, such as 12 volts, to reduce the risk of electric shock. The low voltage power supply for underwater lighting must be located a safe distance from the pool or spa and must be protected by a GFCI. Wiring methods used in pool and spa areas must be suitable for wet locations and must be installed in accordance with the NEC. This may involve the use of rigid metal conduit, intermediate metal conduit, or liquid-type flexible metal conduit. Direct burial cables must be specifically listed for that purpose and must be buried at the required depth. The electrical panels and junction boxes must be located a safe distance from the pool or spa and must be protected from moisture. The NEC specifies minimum clearances for electrical equipment around pools and spas to prevent accidental contact with water. Regular inspections and maintenance of pool and spa electrical systems are essential to ensure continued safety. This includes checking bonding connections, testing GFCIs, and inspecting wiring and equipment for signs of damage or corrosion. Any electrical problems should be addressed promptly by a qualified electrician. Article 680.26 addresses the requirements for equipotential bonding. This section outlines the specific items that must be bonded together to create an equipotential plane, which minimizes voltage gradients in the pool area. The NEC mandates that all metal parts of the pool structure, including reinforcing steel, perimeter surfaces within 3 feet horizontally of the inside wall of the pool, and metal fittings within or attached to the pool structure, must be bonded together. This ensures that all metal parts are at the same electrical potential, reducing the risk of electric shock. The bonding conductor must be a solid copper conductor of at least 8 AWG and must be connected to all metal parts using listed bonding connectors. Article 680.23 outlines the requirements for underwater lighting. This section specifies that underwater lighting fixtures must be listed for use in pools and spas and must be installed in accordance with the manufacturer's instructions. Underwater lighting fixtures must be supplied by a low voltage power supply, typically 12 volts, to reduce the risk of electric shock. The power supply must be located a safe distance from the pool and must be protected by a GFCI. Article 680.22 addresses the requirements for GFCI protection. This section specifies that all electrical circuits supplying power to pool and spa equipment, including pumps, filters, heaters, and lighting fixtures, must be protected by a GFCI. GFCIs are designed to detect even small amounts of leakage current to ground and quickly interrupt the circuit, preventing electric shock. Article 680.21 outlines the requirements for wiring methods. This section specifies that wiring methods used in pool and spa areas must be suitable for wet locations and must be installed in accordance with the NEC. This may involve the use of rigid metal conduit, intermediate metal conduit, or liquid-tight flexible metal conduit. Direct burial cables must be specifically listed for that purpose and must be buried at the required depth. These articles provide specific guidelines for ensuring electrical safety in pool and spa environments. By adhering to these requirements, the risk of electric shock can be significantly reduced, protecting both users and maintenance personnel.